Most students practice the wrong questions. These are 10 ACT questions that high scorers consistently get right. Watch closely, learn the patterns, screenshot them. Because if you can solve these fast, your score jumps. All right, let's read the question. What is 3% of 4.1, 4 times 10 to the fourth? We see 3%. Percent just means divide by 100. So 3% becomes 0.03. Now look at 4.1 4 times 10 to the fourth. 10 to the fourth means move the decimal 4 places to the right. So 4.14 becomes 41,400. Now the problem is much friendlier. We're really finding 0.03 times 41,400. Now we multiply. 0.03 times 41,400 equals 1,242. All right, let's read the expression. Absolute value of 6 minus 4 minus absolute value of 3 minus 8. Always compute inside the absolute value bars first. 6 minus 4 is 2. 3 minus 8 is negative 5. So now the expression becomes absolute value of 2 minus absolute value of negative 5. Now remember what absolute value means. Absolute value is just distance from 0. Distance is always positive, so absolute value of 2 is 2. Absolute value of negative 5 is 5. So now we have 2 minus 5. The answer is negative 3. Correct answer? G. All right, let's read the question carefully. In triangle ABC shown below, the measure of angle A is 58 degrees, and AB is congruent to AC. What is the measure of angle C? We're told two things. Angle A is 58 degrees, and side AB equals side AC. That means this is an isosceles triangle. Now remember the isosceles rule. If two sides are equal, then the angles opposite those sides are equal. Since AB equals AC, the angles across from them, angle B and angle C, must be equal. So angle B equals angle C. We know angle A is 58 degrees, and we know angle B and angle C are equal. Let's call each of those angles x. Now use the triangle angle rule. All three angles in a triangle add up to 180 degrees. So we write 58 plus x equals 180. Combine the x's. 58 plus 2x equals 180. Subtract 58 from both sides. 2x equals 122. Divide by 2. X equals 61. Since x represents angle C is 61 degrees. Correct answer, D. All right, let's read the question carefully. The quadratic function f and triangle MPQ are graphed in the coordinate plane below. Points M, N, and P are on F. Point Q is not on F. In terms of A and B, what is the area of triangle MPQ? Now simplify this. We only need the coordinates of M, P, and Q. We're given M is at 2A, 5B, P is at 6A, 5B, Q is at 4A, 0. Ignore everything else. The parabola doesn't matter for the area. We're just finding the area of a triangle using coordinates. Now notice something important. M and P both have the same y-coordinate, 5B. That means the line from M to P is perfectly horizontal. So MP is the easiest choice for the base. To find the base length, subtract the x values. 6, a minus 2, a equals 4a. So the base is 4a. Now look at point Q. Its y-coordinate is 0. The base sits at y equals 5b. So the height is the vertical distance from 0 up to 5b. That distance is 5b. Now use the triangle area formula. Area equals 1/2 times base times height. So we get 1/2 times 4, a times 5b. Multiply it out. 1/2 times 4 is 2. 2 times 5 is 10. So the area equals 10ab. The area of triangle MPQ is 10ab. Choice G. Let's read the question carefully. We're given f of x equals x squared minus 4, and g of x equals x plus 3. And we're asked, for what values of x does f of g of x equal 0? So what does that mean? It means we plug g into f. we're putting g of x inside f of x. Since f of x equals x squared minus 4, wherever we see x inside f, we replace it with g of x. So now we have f of g of x equals g of x squared minus 4. We know g of x equals x plus 3. So now the expression becomes x plus 3 squared minus 4. That's f of g of x. The problem says solve f of g of x equals 0. So we set x plus 3 squared minus 4 equals 0, add 4 to both sides. Now we have x plus 3 squared equals 4. Now think, what numbers squared give you 4? 2 and negative 2. So x plus 3 equals plus or minus 2. First case, x plus 3 equals 2. That gives x equals negative 1. Second case, x plus 3 equals negative 2. That gives x equals negative 5. So the solutions are x equals negative 5 and x equals negative 1. Correct answer, A. All right, let's read the question carefully. We're given a cosine graph, and we need to decide which equation matches it. Two things always matter with trig graphs: amplitude and period. First, look at how tall the graph is. The middle line is at y equals 0. The highest point reaches 3. That means the amplitude is 3. Amplitude is just the distance from the middle to the peak. So immediately we eliminate anything with a 2 in front. The equation must start with 3 cosine. Now we only focus on the options that start with 3 cosine. Now look at how fast the graph repeats. Start at the peak at x equals 0. Watch where the next peak happens. It happens at x equals pi. That means one full cycle takes pi. That's the period. Now remember the formula. For y equals a cosine bx, the period equals 2 pi divided by b. So we set period equals pi, so pi equals 2 pi divided by b, solve that. b equals 2. That means the inside must be cosine of 2x. We now know amplitude is 3. b is 2, so the equation is y equals 3 cosine of 2x. All right, let's read the question carefully. What is the 275th digit after the decimal in 0 repeating 6295? The repeating block is 6295. That means the digits repeat in this pattern. How many digits are in the repeating block? There are 4 digits, so the pattern repeats every 4 digits. That's the key idea. Every 4 digits, the pattern resets. We want the 275th digit. Since the cycle length is 4, we divide 275 by 4. 4 goes into 275 68 times. 4 times 68 is 272. 275 minus 272 is 3, so the remainder is 3. That remainder tells us which position in the cycle we land on. The repeating cycle is first digit arrow 6, second digit arrow 2, third digit arrow 9, fourth digit arrow 5. Our remainder was 3. That means the 275th digit is the third digit in the cycle. The third digit is 9. The 275th digit is 9. Correct answer, K. Right, let's carefully walk through this ACT question step by step. We are given the equation 1/2 times a times b squared plus c equals d, and the goal is simple. We want to rewrite the equation so that b is alone. Right now, c is being added on the left side. To get rid of it, we subtract c from both sides. That leaves us with 1/2 times a times b squared equals d minus c. So now everything except the b term is on the right. Next, we want to remove that 1/2 in front. The easiest way is to multiply both sides by 2. When we multiply both sides by 2, the 1/2 disappears. Now we get a times b squared equals 2 times quantity d minus c. So the fraction is gone and things are cleaner. But we still don't have b alone. Right now, a is multiplied with b squared, so we divide both sides by a. Now we have b squared equals 2 times quantity d minus c divided by a. Now only b squared remains on the left. The variable is still squared. To undo a square, we take the square root. Taking the square root of both sides gives b equals the square root of 2 times quantity d minus c divided by a. And now b is isolated, Looking at the answer choices, this expression matches answer choice G, so the correct answer is G. All right, let's slow this problem down because this type of question confuses a lot of students. We are told h of f of g of a equals 1, and the question is asking, what number is a? So our goal is to find a. When we see h of f of g of a, this means we are plugging numbers into functions one step at a time. Here's the order. First, we put a into g. Then, whatever number comes out goes into f. Then that result goes into h. And the final result equals 1. So the chain looks like this: a to g to f to h to 1. But solving forward is hard. So instead, we go backwards, because we already know the final answer is 1. So instead of guessing a, we ask, what number went into h to give 1? So we look at the table. We scan down the h column. We ask, where does h give output 1? Looking in the table, we see h of 2 equals 1. That means the input to h had to be 2. So now we know f of g of a equals 2. Now we ask, what number goes into f to give 2? Looking in the f column, we see f of 1 equals 2. So the input to f had to be 1. That means g of a equals 1. Now we ask, what number goes into g to give 1? Looking at the g column, we see g of 5 equals 1. So the number that went into g was 5, and that means a equals 5. So the value of a is 5. Whenever you see stacked functions like this on the ACT or SAT, remember, start from the final output and work backwards through the table. All right, let's read the question first. We are told, given that m is between 1 and 4, n is between 4 and 6, and p is between 8 and 10, what is the greatest possible value of m over n multiplied by 1 over p? So the question is asking, what is the largest possible value of this expression? Before we plug in numbers, we need to remember how fractions behave. A fraction becomes larger when the number on top gets bigger and the number on the bottom gets smaller. So, to make this expression as large as possible, we want the top numbers big and the bottom numbers small. Look at the expression m over n multiplied by 1 over p. Notice m is on top of a fraction. N and p are both in denominators, meaning they are on the bottom. So, to make the result as big as possible, we choose the largest possible value for m and the smallest possible values for n and p. From the problem, m can go up to 4, so we choose m equals 4. N can be as small as 4, so we choose n equals 4. P can be as small as 8, so we choose p equals 8. These choices make the fraction as large as possible. Now plug the values into the expression. 4 over 4 equals 1. So the expression becomes 1 times 1 over 8, and that equals 1 over 8. So the greatest possible value is 1 over 8, which matches answer choice D. This question says, in the standard xy coordinate plane, how many points are both 5 coordinate units from the origin and also 2 coordinate units from the line y equals 0? So we need to find how many points satisfy both conditions at the same time. Let's translate each condition into a picture. The origin is the point 0, 0. Now here's an important idea. If you mark all points that stay the same distance from one point, the shape you get is a circle. So every point that is 5 units away from the origin forms a circle centered at the origin with radius 5. The line y equals 0 is just the x-axis. So what does it mean to be 2 units from the x-axis? It means your vertical distance from the x-axis is 2. So your y value must be either positive 2, meaning 2 units above, or negative 2, meaning 2 units below. So this condition gives us 2 horizontal lines, y equals 2 and y equals negative 2. The question says the point must satisfy both conditions. So we are looking for points that lie on the circle and also on those horizontal lines. In other words, we want the intersection points between the circle and those lines. Now let's count. The line y equals 2 crosses the circle in two places, one on the left and one on the right. And the line y equals -2 also crosses the circle in two places. So we get 2 points on top, 2 points on the bottom. That gives a total of 4 points. So the number of points satisfying both conditions is 4, which corresponds to answer choice J. All right, let's read the problem first. In rectangle A, B, C, D shown, segments BE and CE divide the rectangle into three triangles. Given that DE equals 7 centimeters, BE equals 26 centimeters, and CE equals 25 centimeters, what is the length of BC? So our goal is to find the right side of the rectangle, segment BC. Since this is a rectangle, all the corners are right angles. That means we can use right triangle relationships, especially the Pythagorean theorem. We are going to solve this in 2 steps. First, find the width of the rectangle. Then use that result to find the height, which is BC. Look at triangle DEC at the bottom. This triangle is a right triangle. We know DE equals 7, EC equals 25, and we want to find DC. Using the Pythagorean theorem, DC squared plus 7 squared equals 25 squared. So DC squared plus 49 equals 625. Subtract 49 from both sides. DC squared equals 576. Taking the square root gives DC equals 24. So the width of the rectangle is 24. Now we use the top triangle connecting E to B. The horizontal distance across the rectangle is still 24, but vertically, E is 7 units above the bottom. So the total height, which is BC, is h, and the vertical piece from E up to B is h minus 7. Now we use the Pythagorean theorem again. 24 squared plus h minus 7 squared equals 26 squared. Now h minus 7 squared equals 100. Taking square roots gives h minus 7 equals 10. Add 7 to both sides. H equals 17. And h represents the full height of the rectangle, which is segment BC. So the final answer is BC equals 17. And that corresponds to answer choice C. When rectangles contain diagonal segments, look for right triangles and use the Pythagorean theorem step by step. Solve one triangle, then use that result in the next, and that's it.